irreducible polynomial. A polynomial f of x is said to be irreducible. A polynomial f of x is said to be irreducible if it cannot a polynomial f of x is said to be irreducible if it cannot be expressed as product of two polynomials. It cannot be expressed as product of two polynomials such that g of x and h of x. A polynomial f of x is said to be irreducible if it cannot be expressed. If it cannot be expressed as a product of two polynomials such as g of x and h of x, if each degree such that each degree of h of x and g of x, that is g of x and h of x, the degree of g of x and h of x is less than the f of x is called irreducible polynomial. A polynomial f of x is said to be irreducible. A polynomial f of x is said to be irreducible if it cannot be expressed as product of two polynomials or product of three polynomials or product of some polynomial. If it cannot be expressed as a product of polynomials like g of x and h of x, where degree of the g of x and h of x is less than f of x, is called the irreducible polynomial. Is called what? Irreducible polynomial. If a polynomial f of x is said to be irreducible, it cannot be expressed as a product of polynomials. A polynomial f of x is said to be irreducible if it cannot be expressed as a product of polynomials. It cannot be expressed as a product of polynomials. Let us take one example here. 2x plus 1. Take 2x plus 1 as one polynomial. It can't be expressed as a product of two polynomials. 2x plus 1 can't be expressed as a product of two polynomials. So 2x plus 1 is a irreducible polynomial. 2x plus 1 is a irreducible polynomial. For example, x square plus 7x or 2x plus 9x. X square plus 2x plus 9. Take 9. X square plus 2x plus 9 is also a irreducible. Polynomial. X square plus 2x plus 9. X square plus 2x plus 9 is a irreducible polynomial. Can't be expressed as a product of two polynomials. Why? Because observe here, b square value 4 minus b square 2 square means 4 minus 4ac means we get discriminant is less than 0. So b square minus 4ac discriminant is less than 0. Can't be expressed as a product of two polynomials in terms of real number system. So this is not a reducible polynomial. That is irreducible polynomial. Irreducible polynomial means what? A polynomial f of x is said to be irreducible if it can be expressed as a product of polynomials. It can be expressed as a product of two polynomials. That means h of x and g of x. The h of x and g of x degree is always the less than the f of x. Then the polynomial is called what? Irreducible polynomials. If the polynomial f of x is not a, the polynomial f of x is not a irreducible polynomial, not a irreducible polynomial, that is called reducible polynomial. If the polynomial f of x is not a irreducible polynomial, then it is called a reducible polynomial. That is called a reducible polynomial. Observe here, the linear polynomial, this is linear polynomial. The linear polynomial is always irreducible polynomial. Why? Because this polynomial not expressed as a product of the two polynomials. So the linear polynomial is always irreducible polynomial. Next, if a not equals to 0, ax square plus bx plus c, if a is not equal to 0, ax square plus bx plus c is a irreducible polynomial. Is a irreducible polynomial if b square minus 4ac, that means discriminant is less than, is a irreducible polynomial if discriminant is b square minus 4ac is less than 0. Irreducible polynomials means the polynomial f of x can't be expressed as a product of two polynomials. Observe here, the polynomial f of x is said to be irreducible if it cannot be expressed. If it cannot be expressed as a product of two polynomials like h of x and g of x, then f of x is said to be irreducible polynomial. Then f of x is said to be what? Irreducible polynomial. Otherwise, then it is called reducible polynomial. If you take x square minus 4 is a reducible polynomial. X square minus 4 is a reducible polynomial. Why? Because x square minus 4 can be expressed as x plus 2 into x minus 2. X square minus 4 is a reducible polynomial. Why? Because this can be expressed as product of two polynomials. X square minus 4. This is a square minus b square. A square minus b square equals to a plus b into a minus b. So x square minus 4 is a reducible polynomial. Why? Because this is expressed as a product of two polynomials. Observe here, x square minus 4 expressed as x plus 2 into x minus 2. X plus 2 into x minus 2. So x square minus 4 is a reducible polynomial. X square minus 4 is a reducible polynomial. This is 2x plus 1 is a irreducible polynomial. We can't express as a product of two polynomials. So 2x plus 1 is a irreducible polynomial. Observe that x square plus 2x plus 9 is a irreducible polynomial. Why? Because this is can't expressed as a product of two polynomials. So that's why these polynomials are called irreducible polynomials. Otherwise, then these are what? Reducible polynomials. Next, division algorithm for a polynomial. Division algorithm division algorithm for a polynomials. Division algorithm for a polynomials means let f of x and g of x, let f of x and g of x be two polynomials. Let f of x and g of x be two polynomials and clearly g of x is not equals to 0. Clearly g of x is not equals to 0. Comma, there exists unique polynomials, unique q of x and r of x. There exists unique polynomials q of x and r of x such that f of x or p of x, take p of x here. P of x and g of x be two polynomials. P of x and g of x be two polynomials, and g of x is not equal to 0. There exists unique polynomials. That is q of x and r of x such that p of x is equals to g of x into q of x plus r of x. P of x is equals to g of x into q of x plus r of x is called the division algorithm for a polynomial, where either r of x is equals to, that means remainder is equals to 0, or the degree of r of x is less than the degree of r of x is less than the degree of g of x. Observe here, division algorithm for a polynomial means, let f of x and p of x and g of x, be any two polynomials. P of x and g of x be any two polynomials, and g of x, clearly g of x is not a zero polynomial, nothing but not equals to 0. There exist unique polynomials. That is q of x and r of x. There exist unique polynomials q of x and r of x such that p of x is equals to g of x into q of x plus r of x. In nothing but dividend is equals to divisor into quotient plus remainder. Nothing but p of x in polynomial terms, p of x is equals to, that means p of x is equals to g of x into q of x plus r of x, where either r of x is equals to 0, that means the remainder is equals to 0, or the degree of the r of x, compulsory the degree of the r of x is less than the degree of the g of x. The degree of the r of x is less than the degree of the r of x, g of x. Then it is called what? Then it is called a division algorithm for a polynomial. Yes. Next one is our topic, that is partial fractions. Partial fractions. Partial fraction means if the proper fraction, if a proper fraction is expressed, if the proper fraction is expressed as a sum of two or more proper fractions, sum of two or more proper fractions Sum of two or more proper fractions where in denominator the powers of irreducible polynomials, where in denominators the powers of irreducible polynomials, then each proper fraction in the sum, each proper fraction in the sum is called partial fraction. Is called what? Partial fraction. Observe here, partial fraction means if the proper fraction, we know that proper fraction means in a rational fraction the degree of the f of x is less than the degree of g of x. Less than the degree of g of x is called a proper fraction. So if the proper fraction is expressed as sum of two or more proper fractions. Sum of two or more proper fractions. Observe here, if the proper fraction is expressed as a sum of two or more proper fractions. Sum of two or more proper fractions. Whereas in the denominators, the powers of irreducible polynomials. Already we know that irreducible polynomials means can't express as product of two or more polynomials. That is, polynomials are called irreducible polynomials. Whereas in the denominator, the powers of irreducible polynomials, then each proper fraction in the sum, is called the partial fraction. Observe here, if the proper fraction is expressed as a sum of, proper fraction means proper fraction expressed as sum of two or more proper fractions. Proper fraction expressed as sum of two or more proper fractions, where in denominator the powers of irreducible polynomials, then each proper fraction is called a partial fraction of the given polynomial. Then each proper fraction in the sum is called a partial fraction of given polynomial. Given proper fraction. Understood? Partial fraction means if proper fraction is expressed as two or more proper fractions. Proper fraction expressed as two or more proper fractions. In the denominator, where in denominators, powers of irreducible polynomials, then each proper fraction in the sum, is called a partial fraction of the given proper fraction. Let us discuss an example here. Already we know that the sum of any two proper fractions is always a proper fraction. Let us take one example that is already discussed, that is 2 by x plus 4 and 3 by 2x plus 3, 2 by x plus 4 and 3 by 2x plus 3. There is some already we get 2 by x plus 4 plus 3 by 2x plus 3, 3 by 2x plus 3. There is some already we get how much? 7x plus 18 by 2x square plus 11x plus 12. 2x square plus 11x plus 12. Observe here, 7x plus 18 by 2x square plus 11x plus 12 is a proper fraction. Is a proper fraction. This can be expressed as sum of two polynomials is nothing but 2 by x plus 4 plus 3 by 2x plus 3. 7x plus 18. 7x plus 18 by 2x square plus 11x plus 12. 2x square plus 11x plus 12 can be expressed as 2 by x plus 4 plus 3 by 2x plus 3. This is, observe here, this is a proper fraction. Proper fraction is expressed as a sum of two proper fractions. Sum of two proper fractions. In the denominator is irreducible polynomials. X plus 4 can't be expressed as again the sum of two polynomials. Observe here, 2x plus 3 also can't be expressed as the sum of two polynomials. So 2x plus 3 and x plus 4 are irreducible polynomials. In the sum, each polynomial in each proper fraction. In the sum, each proper fraction is called the partial fraction of the given fraction. In the sum, each proper fraction is called the partial fraction of the given fraction. Understood? Partial fractions means proper fraction. Clearly 7x plus 18 by 2x square plus 11x plus 12 is a proper fraction. Here the degree is 1, here the degree is 2. Proper fraction means the degree of f of x is less than the degree of g of x. Clearly this is proper fraction. The proper fraction is expressed as a sum of two or more proper fractions. Sum of two or more proper fractions. Where in the denominators are irreducible polynomials. Observe here, x plus 4 is an irreducible polynomial. Can't be expressed as sum of two or more polynomials. 2x plus 3 is an irreducible polynomial. Already we know that. Linear polynomial is always irreducible polynomials. So 2 by x plus 4 plus 3 by x, 2x plus 3 is a here each proper fraction is the partial fraction of the given proper fraction. Each proper fraction is the partial fraction of the given proper fraction. This is partial fraction. Okay, that is partial fraction. Partial fraction means what? If a proper fraction expressed as sum of two or more proper fractions. If a proper fraction expressed as sum of two or more proper fractions is nothing but a partial fractions. Okay, proper fraction means easily how to get the partial fraction is okay. How to, that is which is an improper fraction. If f of x by g of x is a rational and improper fraction, is a improper fraction. If f of x by g of x is improper fraction, how to convert into partial fractions? Means, first of all, we divide g of x. Clearly g of x is not equal to 0. G of x, I'll take p of x here. P of x by g of x. Anyone, no problem. P of x by g of x is an improper fraction. How to convert it into partial fraction means, first g of x divided by p of x. P of x is divisible by g of x up to p of x is divided by g of x. P of x is divided by g of x up to we obtain another polynomial r of x. The degree of r of x clearly less than the degree of r of x less than the degree of g of x less than the degree of g of x. If they gave the improper fraction, how to convert it into partial fractions means, First of all, p of x is divided by the g of x up to we obtain the r of x. The r of x degree is lesser than the g of x. Then we express p of x by g of x. Then we express p of x by g of x is quotient plus quotient is nothing but q of x plus r of x by g of x. R of x by g of x. P of x is by g of x is a p of x by g of x is a improper fraction. P of x by g of x is a improper fraction. How to convert into partial fraction means p of x is divided by the g of x up to we obtain the r of x. The degree of the r of x is less than the degree of the g of x. Then this equation can be expressed as like this: p of x by g of x. Clearly, this is improper fraction is equals to quotient plus r of x by g of x. Quotient plus r of x by g of x. R of x by g of x. R of x by g of x is nothing but clearly proper fraction. Why? Because the degree of r of x is less than the degree of g of x. So r of x is by g of x is a proper fraction. This proper fraction again we use we convert it into partial fractions. Observe here, p of x by g of x is a improper fraction. How to convert the improper fraction into partial fractions means p of x is divided by the g of x. We get r of x and q of x. Clearly, r of x degree is less than the g of x. This can be expressed as p of x by g of x is equal to q of x plus q of x is nothing but quotient plus r of x by g of x. Quotient plus r of x by g of x. R of x is nothing but remainder by g of x is nothing but dividend. Sorry, divisor. Remainder by divisor. Here r of x by g of x is a proper fraction. Next, it is converted into partial. That is partial fractions. How to resolve the proper fraction and the improper fraction. Observe here. Next topic is types of partial fractions. How to resolve the partial fraction? If the proper fraction is given, how to resolve into partial fractions means the partial fractions depend upon the nature of the factors, the denominator, nature of the factors of the denominators. If the denominator has non-repeated linear factors, how to resolve into a partial fractions? When the denominator has repeated linear factors, how to resolve the given proper fraction into linear proper fractions? That means partial fractions. And the denominator has quadratic expression and irreducible factors. How to resolve into partial fractions? Let us discuss one by one. First one is type 1. When the denominator has non-repeated linear factors. When the denominator has, first type 1, that is rule 1, when the denominator has non-repeated linear factors. When the denominator has non-repeated linear factors. That means if f of x by g of x is a polynomial, this is proper fraction. F of x by clearly g of x is a proper fraction. F of x by g of x is a proper fraction. Then the factors of the g of x, that is g of x, then the factors of the g of x clearly non-repeated linear factors. That means if you take x minus a, x minus b, x minus c, and so on like this. That means x minus a, x minus b, x minus b, c. That is non-repeated linear factors. Non-repeated linear factors. How to resolve into partial fractions. That means f of x by, that can be written as f of x by, that is x minus a into x minus b into x minus c. The partial fractions depends upon the factors of nature of factors of the denominators. Nature of the factors of the denominator. First one is when the denominator has non-repeated linear factors. When the denominator has non-repeated linear factors, how to find the partial fractions? How to find the partial fractions is, let us f of x by g of x. F of x by g of x is a proper fraction. That is, g of x is clearly g of x is a non-repeated linear factors. Non-repeated linear factors. Nothing but g of x equals x minus a, x minus b, x minus c, x minus c. Non-repeated linear factors. That means f of x by x minus a, x minus b, x minus c. Let us assume that this value is a by x minus a by x minus a plus b by x minus b plus c by x minus If it is so on, let us take a1 by x minus a1, a2 by x minus a2, a3 by x minus a3, a4 by x minus a4, and so on. Otherwise, this is the fraction, proper fraction g of x is a linear, non-repeated fraction means x minus a. That means f of x by g of x. G of x is equal to, that is a1 by x minus a1 plus a2 by x minus a2 plus a3 by x minus a3 plus and so on an by x minus an. If it has n terms, n linear factors. If it has n linear factors, that is taken as like this: f of x by g of x is equal to a1 by x minus a1 plus a2 by x minus a2 plus a3 by x minus a3 and so on up to an by x minus a. If it has n linear factor means, let us take this one. If it has like this x minus a and x minus b and x minus c, that is f of x by x minus a and x minus b and x minus c is equal to a by x minus a plus b by x minus b plus c by x minus c. How to find the values of a, b, c means a is equal to clearly f of a by here where a is equal to f of a by, we want a value and b value and c value. How to find the values of a and b? Let us discuss one example next. Here observe here, a value is f of a by a minus b into a minus c. F of a value is clearly f of a by a minus b into a minus c, and b value clearly f of b by f of x means what? F of x is a numerator given polynomial, and g of x is f of b by, that is b minus a into b minus c, and c is equal to f of c by, that is c minus a into c minus b. These are the values of a, b, c. Otherwise, f of x by x minus a into x minus b into x minus c is equal to a by x minus a plus b by x minus b plus c by x minus c. If you do LCM and compare both LHS and RHS, and we get ABC values. When the denominator has non-repeated linear factors, that means the denominator g of x has a x minus a as the factor. Then f of x by g of x, if it has n factors, that means f of x by g of x is equal to a1 by x minus a1 plus a2 by x minus a2 plus a3 by x minus a3 and so on an by x minus an. If you do LCM here, and compare LHS and RHS and substitute the values of x, a1, a2, a3, we get a1, a2, a3 values that then we convert into partial fractions. Let us discuss one example here. Example. If you take one example, 5x plus 1 by x plus 2 into x minus 1. Let us discuss one example. 5x plus 1 by x plus 2 into x minus 1. x plus 2 into x minus 1. This is clearly proper fraction. This is clearly proper fraction. We want partial fractions. Partial fractions means if you have proper fraction expressed as a sum of two or more proper fractions is called a partial fraction. So resolve into 5x plus 1 by x plus 2 into x minus 1 as a proper fraction means let us assume that resolve into 5x plus 1 by x plus 2 into x minus 1 is a partial fraction means is a partial fraction. This is question. Answer is let us assume that 5x plus 1 by x plus 2 into x minus 1 is equals to a by clearly x plus 2 into x minus 1. X plus 2 into x minus 1 denominator has non-repeated linear factors. X plus 2. Another one factor is x minus 1, not x plus 2. So another factor is x plus 1. Clearly denominator has non-repeated linear factors. Non-repeated linear factors. Then 5x plus 1 by x plus 2 in 5x plus 1 by x plus 2 into x plus 1 is equals to, let us assume that a by x plus 2 plus next one is b by x minus 1. b by x minus 1. We want a and b values. How to find the a and b values is after here. If you do LCM here, we get 5x plus 1 by that is x plus 2 into x minus 1 is equals to, if you do LCM here, the LCM is x plus 2 into x minus 1, that is x plus 2 into x minus 1 is LCM. X plus 2 get cancelled, we get a into x minus 1 plus x minus 1 get cancelled, we get b into x plus 2. b into x plus 2. So denominators x plus 2 into x minus 1, x plus 2 into x minus 1 both are to get cancelled. Compare with this one, 5x plus 1 is equals to a into x minus 1 plus b into x plus 2. a into x minus 1 plus b into x plus 2. If you substitute x is equals to 1, putting x is equals to 1, we get b value. Putting that means if you do a value 0, we get b value. So putting x is equals to 1, x is equals to 1, we get 5 into 1, 5 plus 1 is equals to a into 0 plus b into 1 plus 2 is nothing but 3. So 5 plus 1, 6 is equals to 3b, b is equals to, we get b value. If you do this is 0, we get b value. If you do putting b is if x is equals to minus 2, if x is equals to minus 2, we get 5 into minus 2, minus 10 plus 1. 5 into minus 2 is nothing but minus 10. Minus 10 plus 1 is equals to a into minus 2 minus 1 plus b into minus 2 plus 2 is nothing but 0. So minus 9 is equals to minus 3a. A is equals to how much? Minus 9 by minus 3 we get. So a value 3 and b value 2. So this can be written as we want partial fractions, that is clearly 5x plus 1 by x plus 2 into x minus 1. X minus 1 is equals to, that is a value how much? We get a value 3. So 3 by x plus 2 plus b value we get 2 by x minus 1. So this is the proper fraction. We resolve into partial fractions like this: 3 by x plus 2 plus 2 by x minus 1. So 3 by x plus 2 and 2 by x minus 1 are the partial fractions of the given proper fraction. 3 by x plus 2 and 2 by x minus 1 are the partial fractions of the given proper fraction. This is the first method. When the denominator has non-repeated linear factors. Non-repeated linear factor. That means g of x has x minus a as a factor. That means x minus a1 and x minus a2 and x minus a3 and x minus a4. Then the f of x by g of x can be written as a1 by x minus a1 plus a2 by x minus a2 plus a3 by x minus a3 plus and so on an by x minus an. We do first of all LCM and compare with LHS and RHS. We get A, B, C and A1, A2, A3 values and substitute here we get partial fractions. So find x plus 1 by x plus 2 into x minus 1 is equals to 3 by x plus 2 plus 2 by x minus 1 are the partial fractions of the given proper fraction. This is first method. Next method, or otherwise, if you substitute, observe here, a value is nothing but f of a by a minus b into a minus c. That is, if a value, this is here, a value how much? A value 2. A value how much? X plus 2. So, if you substitute minus 2 in this one, f of minus 2 by, and direct formula, this is substitute minus 2, we get a. Substitute minus, that is 1, we get b. Substitute b value 1 in this equation, we get b value, and substitute minus 2, we get directly this one. Or otherwise, this is easy process, continuous. This is x. Yes, type 2. That is when the denominator has repeated linear factors. Type 2. Then the denominator has repeated linear factors. When the denominator, when the denominator has repeated linear factors, if the denominator contains repeated linear factors, how to convert it into partial fractions is, observe here, the denominator f of x by g of x is a rational fraction. F of x by g of x is a proper fraction. Then g of x contains the what? G of x contains the repeated linear factors. That means g of x contains repeated linear factors, that is x minus a whole to the power n, x minus a whole to the power n. Then corresponding partial fraction derivative. When the denominator contains a repeated linear factors, how to convert it into partial fraction is, that is f of x by, it is in the form of x minus a whole to the power n. This can be written as a1 x minus c and plus a2 by x minus a whole square plus a3 by, observe here, x minus denominator, x minus a up to n times. So this is a repeated linear factors. When the denominator has a repeated linear factor, how to convert it into partial fractions is f of x by x minus a whole power n is equals to, assume that a1 by x minus a up to n degree. So a2 by x minus a whole square, a3 by x minus a whole cube plus and so on up to an by x minus a whole to the power. Up to an by x minus a whole to the power. If the denominator has contained repeated linear factors or ax plus b whole to the power n. So f of x by ax plus b whole to the power n is equal to a1 by ax plus b plus a2 by ax plus b whole square, a3 by ax plus b whole cube and so on an by ax plus b whole to the power n. When the denominator has repeated linear factors. Or like this also, when the denominator it is in the form of g of x, it is in the form of x minus a whole square into y minus b. If the denominator g of x contains x minus a whole square into y minus b, then f of x by f of x by g of x is nothing but x minus whole square into y minus b. Half take x minus b whole, x minus b, x minus b, x minus a whole square. This is the one of the linear factor. This is also one of the linear factors. X minus a whole square into x minus b. This can be taken as a by x minus a plus b by x minus a whole square plus. This contains repeated linear factors and also non-repeated linear factors. So in this type we use first and the second method also. So if a by x minus a whole square, x minus a whole square means this is repeated linear factor. So x minus a whole square can be written as a by x minus a plus b by x minus a whole square plus. Here it contains non-repeated linear factors. So that is c by x minus b. First of all, it can be written as like this, and if you do LCM and compare LHS and RHS, we get ABC value right here. We convert it into, so f of x by g of x is converted into partial. Type 2, when the denominator contains repeated linear factors. Repeated linear factors is nothing but x minus a whole to the power n. X minus a whole to the power n, or ax plus b whole to the power n, any linear factor, repeated linear factors. How to convert it into partial fractions means, so f of x by x minus a whole to the power n, f of x by x minus a whole to the power n. Observe here, denominator has contained repeated linear factors, This type of proper fraction, how to convert it into partial fractions means, this can be written as, that is a1 by x minus a, a2 by x minus a whole square plus a3 by x minus a whole cube plus and so on, an by x minus a whole to the power. Or if you denominator contains like this, x minus a whole square into x minus b. That means x minus a whole square means it contains the repeated linear factors and non-repeated linear factors. How to convert it into partial fractions means f of x by x minus a whole square into x minus b means a by x minus a plus b by x minus a whole square. This is a repeated linear factors. So this can be written as a by x minus a plus b by x minus b. Again, non-repeated linear factor is there. So this is c by x minus b. So here we are doing LCM and compare LHS and RHS, we get ABC values. Let us discuss one example here.